These are your Section 5 notes on speciation through isolation. So your objectives are going to be to talk about and explain how isolation of populations can lead to speciation, and then also to describe how populations can become isolated. So to start, right, that isolation itself, right, what we're looking for eventually is reproductive isolation, because that's when members of different populations would no longer be able to mate successfully. That would be the final step in making separate species. That's when speciation actually occurs. So we actually have a few examples of this. Although we've never been able to see this happen necessarily, we see that final step in multiple cases. Right? Remember, we assume that lions and tigers are related because they can have offspring together. The problem is their offspring can't have offspring, which was the whole idea of mating successfully a long time ago. That's why lions and tigers are considered separate species anyway. Right? Because even though they can have offspring, their offspring cannot have offspring. So we know that they're related, or we would assume that they are. There's some big cat ancestor that both of them have. But at this point, they have reached that reproductive isolation. They are different enough, those two populations are different enough that they can no longer mate successfully, although we know that they can mate, just not successfully. Right, so it's a good example because we know that they can actually cross again. You can end up with that liger or tigon, depending on who the mom is. I think they name it a liger if the lion's a mom, a tigon if the tiger's a mom. But otherwise, we know that those offspring are sterile, that they cannot reproduce. So that's why we know that those are two separate species. And this is evidence of speciation. We know that lions and tigers likely were the same species at one point. Right? They have a common ancestor that makes them related. But through a long period of time, they've reached this reproductive isolation. Same can be true for, remember, donkeys and horses. Because they can reproduce successfully, or semi-successfully, that is. Remember that mule cannot reproduce, which is why donkeys and horses have reached this reproductive isolation. Right? So the whole idea is, yeah, they did manage to have offspring, but it's not really a successful reproduction because neither offspring, the ligers, the mules, can have their own offspring. But again, we know that donkeys and horses likely have a common ancestor because they can reproduce at all. So we have this reproductive isolation. But before you can become separate species, you have to be isolated some way, somehow. If those populations do not become isolated to begin with, they would continue to mate together and mix alleles to stay the same. They would never change from each other. So you have to have something that actually separates two populations before they can become isolated for long enough that they can become different species. And there's three different ways that they can become isolated. So we have behavioral isolation, we have geographic isolation, and we have temporal isolation. They are all different. I would like you to be able to identify the difference in an example for a quiz or a test. But behavioral isolation first is caused by a difference in courtship or mating behaviors. So this is a situation where two populations have individuals that could reproduce together. They just essentially choose not to, right? Because they're looking for certain mating behaviors, one population doesn't end up mixing with the other. So the example for this from the book is a firefly. So you got firefly A, population A, and you got firefly population B. And they're going to stay isolated even though they live in the same place, because Firefly A, and I would assume you know about fireflies, how they flash their abdomen. And the purpose for flashing the abdomen isn't so that you can see it and you can go catch it and put it in a jar. The purpose of flashing is so that it can attract a mate. But Firefly A, its population flashes every 2 seconds, right? There's one flash every 2 seconds, and they're attracting other fireflies that flash one time every 2 seconds. But Firefly population B is a little bit different, right? They're flashing one time every 5 seconds. I believe in the book it said like 5.5 seconds, but we can round off here. It's not a big deal, right? So one population is flashing every 2 seconds. The other population is flashing every 5 seconds. And depending on which population you're in, right, that's what you're attracted to, right? If you flash every 2 seconds, you're attracted to another firefly that flashes every 2 seconds, and vice versa. If you flash every 5 seconds, you're attracted to another firefly that flashes every 5 seconds. So they never really mix together, even though they are the same species. Even though they could reproduce, they don't, and they choose not to. Right, so it's a courtship or mating behavior that separates them. They're isolated due to that. Which again, essentially means that it's a choice, like an active choice. They're only attracted to certain things, that's why they stay separate. That's what makes this behavioral when it's all said and done. Geographic isolation is a little bit different, right? This one's the most obvious one. This is the easiest one to understand, right? So I have squirrel populations in this example. I think it was called a Kaibab squirrel, but I don't really remember how to spell that, nor do I remember how to spell squirrel, so if that's wrong, whatever. But I have population A, and I have population B, but in this case, the reason why they're separated is because they have a physical barrier between them. So one population is living on one side, of the Grand Canyon. The other one's living on the other side. And as you can tell, right, that big gap in between them is preventing them from getting together. Right? So actually the physical barrier could be a lot of different things. In this case, it's a canyon, right, that isolates them. And it's big enough to keep them separate from each other. You couldn't just have a small crack in the ground and assume that they couldn't jump across it. But if it's big enough to separate those two populations and keep them separate, they can end up reaching that reproductive isolation and become new species, like we mentioned earlier. So it's not always a Grand Canyon, obviously. Sometimes it's a mountain range, right? They can't get up and over the mountains, right? Maybe it's a river. Right? Maybe these are things that can't swim, and if you're on one side of the river or the other, it might make a difference. Maybe it's an ocean, right? That's a big separator between continents, right? But it actually can be very small too. There are certain species that won't cross a road, right? Even having a road, a man-made physical barrier for them, right? It's enough to keep them separate from each other. So it doesn't really matter what the physical barrier is, but as long as it's a physical barrier that's separating populations, then it's going to be geographic. Right? Temporal isolation is the last one. And this is the one that's the easiest to confuse. It and behavioral can be kind of weird at first, right, to tell the difference. Temporal isolation occurs due to reproductive timing. Excuse me, I need the highlighter here. And our best example for this, or some of the easiest examples to use, are actually with trees, right? So I can have trees, maybe two populations of trees, and they're actually the same species of tree. They're the same type of tree. But I have population A and population B. And again, just like in the behavioral isolation example, they're not actually separate from each other. One tree is sitting right next to the other, but they don't actually reproduce together because of when they pollinate, right? So you understand that plants have to pollinate. Can't spell right now. I'm not even sure. It's like pollinate, something like this. I don't know. We're guessing. So trees pollinate, but they can also pollinate at different times, right? So maybe population 1 is pollinating right now. Maybe they're pollinating in May, and so all of those trees are reproducing right now as we speak. But population B, they don't pollinate right away. They wait a couple days, right? Wait a couple weeks, maybe wait a month. So population B is going to be pollinating in, June, right? So that is going to make a big enough difference. If they're not pollinating at the same time, there's no way that they can reproduce with each other. So one pollinating in May, the other one pollinating in June, that's going to keep those two populations isolated. They will never mix alleles. They will never mix traits. So they can start to evolve differently. They can change to become different species over a long period of time. So again, there are 3 different types of isolation. There's behavioral, geographic, and temporal, right? Geographic is the easiest. It's just a physical barrier that separates 2 populations. Behavioral and temporal take a second to differentiate, right? If it's a behavior, if those species are actively choosing not to mate with each other, that's one thing. Whereas if it's temporal, right, then it would have to do with when they are reproducing, right? Because I could still have an insect example. Maybe Firefly A is reproducing at dusk, right, when the sun goes down, and Firefly B is reproducing when the sun comes up, right? So they're both using that time of day when it's kind of dark but kind of light so that they can see each other, but they can also see those flashes because it's a little bit darker, right? If it was a timing thing, then it would be a temporal isolation, right? But if it's literally they're reproducing at the same time, they're just attracted to different things, that's a behavioral isolation. So again, I could make the Firefly example a temporal isolation. That's what makes it confusing. So understand the difference. If they're reproducing at the same time, but attracted to different things, then it's behavioral. If they are not reproducing at the same time, then it would be temporal. And when those trees pollinate, that's not necessarily a choice, right? That's just when they do what they do, right? Otherwise, again, difference between behavioral and temporal isolation. I could make that Firefly example go either way, right? If it's dusk versus dawn, that would be temporal. But if it's the 2-second flashing versus once every 5 seconds, that would be behavioral. So understand the difference, right? If the timing's the same, if they're both doing it at dusk, but the difference in flashing is what's causing them to be separate, that's behavioral. But if the timing's different, if it's dusk versus dawn from the get-go, then it wouldn't matter if it was 2 seconds or 5 seconds or 18 seconds. It's still going to be temporal because they don't actually actively choose to not mate with each other. They couldn't if they wanted to because it's a different time of day. Whereas that isolation involved producing differences in species throughout the Galapagos, that would be more of a geographic isolation, right? Especially for the tortoise that's on one island versus another. They couldn't move to one island or the other because they couldn't swim. So they're both stuck in the same place, right? Those two populations are stuck on one island and they're adapting to those islands, and that's why they end up becoming so different, right? Those tortoises were not reproductively isolated yet. It might take 1,000 or a couple thousand more years for that to occur. But eventually we might see that they're completely different species, that they can no longer reproduce successfully. Okay. So that's that for section 5.